In exercise number 3, you will be guided through the tool definition process and its important parameters related to iMachining. The technology wizard will also be covered in greater detail during this exercise. If you haven't already done so, perform step 1 by loading the SolidCAM part used in this exercise. Simply click on the file name exercise3.prz. If SOLIDWORKS is not already opened, SOLIDWORKS, SolidCAM, and the CAM part will launch automatically. Note that a milling CAM part has already been created for this exercise. The CNC machine controller, coordinate system, stock model, and target model are defined. The machine and work material definitions for the iMachining data have also been selected during the CAM part definition process. In step 2, the following actions have to be implemented to define a tool suitable for the CAM project. All iMachining operations in this exercise will use the same tool. In the SolidCAM Manager, double-click the tool header to display the Part Tool Table dialog box. Currently, the Part Tool Table is empty. Click the Add Milling Tool button to start the tool definition. When the new pane containing available tools is displayed, choose End Mill from the Milling Tools list. Under the Topology tab, you can define the physical dimensions of the tool. There are 3 important parameters that affect the cutting conditions generated by the Technology Wizard. They are the diameter, cutting length, and number of flutes. Working from top to bottom, first set the tool diameter. Enter a value of 12 mm in the input field text box. Next, set the cutting length. This is important. For this exercise, use the default value of 24 mm. The wizard uses the cutting length to calculate if multiple steps are needed to achieve the pocket depth. Setting the correct number of flutes is also important. This will ensure the proper chip size is given to each flute. The tool used in this exercise has 5 flutes. In any given machining situation, you will use a tool with a specific number of flutes. Changing the number of flutes will change the cutting conditions, usually just the feed rate. When using iMachining, you may find that matching a tool with a specific machining situation will give you more desirable cutting conditions provided by the wizard. Switch to the iData tab of the Part Tool Table dialog box. Here, you can define parameters even more specific to iMachining. The material database is automatically selected using the CAM part default. This work material is defined during the CAM part definition process. Although, it is possible to set a different work material definition for each tool. Selecting a different work material definition is typically used when machining different materials in one CAM project. A fixture is a good example of this. If you click the arrow in the Material Database section, the dropdown will display the 70+ materials that are supplied with the system, plus any new entries that have been added to the database. For the purpose of this exercise, leave the default selection, aluminum with a 100 Brinell hardness number and a hardness Rockwell of 60 on the B scale. In the Tool Material section, iMachining enables you to select a given type of material from which the tool is made. The tool material selection affects the cutting speed adjustments generated by the wizard. The default selection is carbide at 100%. By selecting a different tool material using the drop-down menu, a percentage adjustment will be used to calculate the maximum cutting speed. If necessary, an override checkbox is provided so a percentage adjustment can be set manually as well. For this exercise, use the default tool material selection of carbide at 100%. In the machining level section, the selected default level will position the slider to this level in the Technology Wizard when choosing this tool from the Part Tool table. Currently, the assigned machine default level of 6 is automatically used by default. For this exercise and this particular tool, set the default level to 5. The helical angle parameter is especially important for calculating depths based on axial contact points, or ACPs. Changing the helical angle of the flutes will only change the ACP indication, and the wizard will alert you whether or not the situation for stability is good based on the ACP value and color of the step-down row. The ACP value calculated and displayed by the wizard currently has no effect on the cutting conditions. Though the closer the ACP is to a whole number, the less likely it is that vibrations will develop. You may have to decide to change the tool and accompanying helix angle of the flutes to achieve good ACPs and avoid vibrations. When cutting, keep in mind that the helix angle of the flutes has a strong effect on the downwards force on the tool and should be monitored. There are 5 typical tool helix angles to choose from, or you can also type in a value. For this exercise, use the default 45 medium value for the helical angle parameter. Click the OK button to save the tool definition and exit the part tool table. At this stage, the tool definition process in step 2 is complete. If you have not followed along, apply and practice the procedure shown in this video to define the tool for the CAM project.